Let's take another look at another example of solving a rational equation. Again, we want to find the common denominator so that we get all the common denominators equal, and then we can write the equivalent equation down. I'm probably going to do it that way. But before we do that, we're going to have to look at the denominator. Now notice this here is a difference of two perfect squares. Again, like we were adding and subtracting rational expressions, we want to make sure all the denominators are factored. So when we have polynomials, trinomials and binomials, we need to make sure that they are factored completely before proceeding to follow the step of finding the common denominator. So that we can see all the factors in the denominator, we know which ones are missing and which ones aren't. So if you look at p squared, okay, minus 9, don't forget that's the difference of two perfect squares. So p times p gives me p squared, and then 3 times 3 gives me the 9, and one is positive, the other one is negative. So I am going to replace that denominator with those two factors. Okay? And I'm going to write this over 1 so that you can see that the denominator is 1, and then p plus 3 for the second fraction on the right hand side, and then the denominator to the left side has p plus 3 times p minus 3. So now everything is factored, so now it's going to be much easier for me to identify the common denominator. And it's going to be p plus 3 times p minus 3. And this is going to be the LCD. Okay, it's going to be p plus 3 times p minus 3. Okay, and we know that because this denominator has the p plus 3 and the p minus 3 off to the left, right? This one just has the p plus 3, so it's missing the p minus 3. So we're going to multiply p minus 3 top and bottom. This denominator is 1, so again it's missing both of them. So we're going to times the top and bottom by both of those factors, okay? That's why it's so much easier if you factor everything, so you can see exactly what's missing, all right? So what this comes down to is that we basically have this. We basically have 36 all over p plus 3 times p minus 3 equals. And then here we have 2p times p minus 3 all over, again, the same two factors, minus, and then 1 times p plus 3, p minus 3, okay, all over. All right. I shouldn't even put the 1 there. I mean, it's understood. 1 times those two factors are those two factors, but that's okay. As long as you understand that the common denominator is so you just do that, okay? Now, since the denominators are all the same, okay, we can go ahead and write the equivalent fraction, all right? So remember, the denominators are identical. They're identical here, here, and here. So this is going to be your equation, 36, okay, equals all of this, all right? So we can go ahead and write that down and start solving it, okay? So we basically have 36 equals 2p times p minus 3. Now 1 times all of that is just going to give me the same thing back, okay? Actually, let me just write it out so I don't want to confuse anybody. All right, And then now, let's go ahead and we need to sort of solve this equation, okay? So unfortunately, we're going to have to FOIL this out. We're going to have to distribute the 2p with the p minus 3 and then FOIL the p plus 3 and the p minus 3. So a little bit of work, but you know, it's doable, okay? We can do that. So we're going to take 2p times p, okay? And then we're going to take 2p times minus 3, all right? So when we do that, okay, we're going to get 36 equals 2p squared, and then 2p times minus 3 is 6p. Okay, you see what I did there? All right, so now we are going to FOIL this, right? P times p, which is going to be p squared, and then we're going to do p times minus 3, which is minus 3p. Okay, so that's what we do. All right, and then that's going to give me, all right, p squared, and then p times minus 3 is minus 3p. Okay, and then now do the inner, which is 3 times p, which is plus 3p. Okay, I should have changed the color here. So let me go back to the color here. So that's plus 3p. And then now we're going to do the outside, or the last, excuse me, 3 times minus 3, which is basically minus 9. All right, so you FOIL those two, and then you times that whole polynomial by a minus 1. Okay. And that's why I kept it there, so you can see step by step exactly what I'm doing, in case some of you are struggling with FOILing polynomials. You want to make sure that you understand all the steps. Okay, so basically you have 36 equals 2p squared minus 6p, and then don't forget, you notice that the minus 3p and the plus 3p, okay, those are going to cancel out, okay? So you are just left, all right, with p squared minus 9. You see that? Okay, you're just left with p squared minus 9. All right, so it's basically minus 1 times p squared minus 9. All right, and that just made life a lot simpler because we were able to get rid of some terms there, okay? And then, of course, you have 36 equals 2p squared minus 6p. Again, we're going to distribute that minus 1, so that's minus p squared plus 9. See how that works? And we're going to go back over here, all right, and start collecting like terms. And we can do that now, okay? The 36 equals, so we want to do 2p squared minus 1p squared, which is just p squared, okay? All right, and then minus 6p, and then plus 9. Okay, so we're in good shape. We're almost there. All right. Notice that this is a polynomial. It's turning into a trinomial. So we're going to have to get all the terms on one side and get 0 on the other, because when you have a polynomial equals to 0, again, we want to factor it and set all the factors to 0. That's called the zero product property. Okay, so what we're going to do is we're going to subtract 36. All right, and when you do that, okay, you're going to get 0 equals p squared minus 6p minus 27. Okay, I apologize. So basically we want to do is we want to factor this trinomial, okay? And basically what we do is this is going to be a simple trinomial to factor because the coefficient next to the p squared is 1, and then we want to find all the factors 27. So I'm going to choose 3 and 9 because 3 and 9 give me 27 when I multiply it, but they also give me a difference of 6 when I do the subtraction. So I'm just going to use trial and error here, okay? So you find all the factors of 27. We can do that because the coefficient of the a coefficient, which is next to the p squared, is 1. So I'm going to pick, well, p times p, by the way, gives me p squared. And then I'm just going to choose 3 and 9, okay? But I'm going to rearrange them. I want to put the 9 here and the 3 here. Okay, because, and I want to make the 9 negative and the 3 positive. And here's what we want to check. We want to check to see if we get negative 6p in the middle. So you basically test the outer, all right? P times 3 is 3p, and then you do the inner. Okay, negative 9 times p is negative 9p. So if you do plus 3p minus 9p, you're going to get the negative 6p, so you know it works. So order of the 9 and the 3 matters in this case. If you were to put the 3 in the 9, then you would not be able to get the negative 6p, so you would just switch the location. So some of the trickier trinomials will do that, where you have to arrange the 3 and the p, the two numbers a certain order so that you get the middle term. So now that we did that, okay, we're going to apply the zero product property. That means when these two factors multiply to give me 0, I can simply set each one individually to 0 and solve. Because again, we want to solve this equation. We're not just factoring it, right? We want to solve it. So we need to take this extra step and then go ahead and set both factors to 0 and then simply solve for p. Well, if I add 9 here, I'm going to get p equals 9. That's one of my solutions. And then here I'm going to subtract 3. And then I'm going to get p equals minus 3. So these are your two solutions that I get when I factor, okay? And we want to make sure that we check these solutions, okay? So if you substitute 9 into the original equation is all the way up here, okay? We want to make sure that you get minus 1. We want to make sure that the two numbers you get on each side equal each other. And if it does, then it's a solution. However, when I plug in negative 3 into the original equation, I don't get two equal numbers. So that's not going to work. Okay? So what we got to make sure is that we're going to check the solution, because if we don't check it, all right, so we're going to check p equals 9. So again, we're going to use our original equation, 36 divided by p squared minus 9 equals 2p over p plus 3 minus 1. So if I substitute it in here, I get 36 over, okay, 9 squared minus 9 equals, all right, 2 times 9 over 9 plus 3 minus 1. Again, I'm simply substituting the number for p into the original equation. And when you do all of this, you're going to get 1/2 equals 1/2. And that's going to work, okay? But if you check the other solution, the potential solution, p equals minus 3, okay, again, you're going to just substitute it in, so you're going to get, I'm going to use parentheses because you have the minus here, okay? And we want to make sure that it equals, well, what's going to happen is if you do this math here, negative 3 squared is 9, and then 9 minus 9, okay, we don't even have to simplify anything else because negative 3 plus 3 is 0, okay. The minute you have the denominator, if you're trying to divide by 0, that's going to make this thing undefined. You can't get a 0 equals a number, so this is not going to be the solution, okay? This is not going to be the solution, so we're going to cross that out. Only this is the solution, p equals 9. So just keep in mind when you do a problem like this.